In this session, let us review trigonometric ratios and some basic equations. Now let us consider this triangle ABC here, which is a right triangle, and the base is B and the height is A, as you can see, and the hypotenuse is H, and let the angle A be theta. Now we know that's the ratio sine theta is equal to A by H, that is the side opposite to angle theta, and divided by the hypotenuse H, and cos theta is equal to B by H, that is the base by the hypotenuse H, and tan theta is sin theta by cos theta, which will be A by B, the side opposite to theta divided by the base B. And likewise, we know that cosec theta is the inverse of sin theta, that is H by A in this case. Sec theta is the inverse of cos theta, which is H by B, and cot theta is the inverse of tan theta, which is B by A. Now let us write the basic trigonometric equations that you've learned in the previous standards. From the Pythagoras theorem, we know that A squared plus B squared is equal to H squared. Now if we divide both sides by H squared, we would get A by H whole squared, which is sine squared theta, plus B by H whole squared, which is cos squared theta, is equal to 1. H by H whole squared, which is 1. And if we divide both the sides by B squared, let's see what it will become. So it will be A by B whole squared, which is tan squared theta. Let's write that here. Plus B by B whole squared, which is 1, is equal to H by B whole squared, which is sec squared theta. And finally, let us divide both the sides by A squared. So it will become A by A whole squared, which is 1, plus B by A whole squared, which is cot squared theta, is equal to H by A whole squared, which is cosec squared theta. So these three are our basic trigonometric equations. Now let us try to calculate the values of the sine, cos and tan theta for some selected values of theta. So we will write possible values of theta here: 0 degrees, 30 degrees, 45 degrees, 60 degree and 90 degree, and we will calculate sine theta, cos theta and tan theta for these values of theta. Okay, and let's draw a neat table so that it becomes clear when we write it. Now let us represent 0 degrees through a small triangle here. Let this base be A, this vertical side be B, and the hypotenuse be H, and the angle here be theta. Now the small angle theta, as it tends to 0, we can see that the vertical side B vanishes. It becomes close to 0, right? And therefore the base A and the hypotenuse H, they overlap and become equal, and therefore we can say by intuition that sine of 0 degrees is equal to B by A but b is 0, and therefore this is 0. Cos of 0 degrees is a by h, and the two sides become equal when theta tends to 0 degrees, so this is equal to 1. And tan theta is sin theta by cos theta, so that will be 0. Now let us draw a triangle whose one angle is 30 degrees, something like this. Let us again label the base as A, this vertical side as B, and the hypotenuse as H. Now if we draw a replica of this triangle and draw it upside down in such a way that its base now coincides with the base of the previous triangle, so it will look something like this. Now these two angles on the left here, each is 30 degrees, so therefore this total angle on the left in the bigger triangle will become 60 degrees, and we already know that this particular angle out here is 60 degrees, and this other angle out here is also 60 degrees. So therefore this bigger triangle, which is a combination of the two congruent right triangles, is an equilateral triangle, and therefore the three sides of this bigger triangle, they are equal, and h is equal to 2b, and a is equal to under root of h squared minus b squared by Pythagoras theorem, which is square root of 4b square minus b square, which is equal to root 3b. Therefore, for this angle theta, sin theta is equal to b by h, which is 1 by 2. Cos theta is equal to a by h, which is root 3 by 2. And tan theta is equal to b by a, which is 1 by root 3. Now if we draw a right triangle with an angle of 45 degrees, we know that it is an isosceles triangle. Here this theta is 45 degree, and so is this other non-right angle, and therefore the base and the height of this triangle are same. That is, these two sides are equal. A is equal to b, and the hypotenuse h is equal to a squared plus b squared, which is square root 2 times a, and therefore sine 45 degrees is equal to b by h, which is 1 by square root of 2. Likewise, cos 45 degrees is 1 by square root of 2, and tan 45 degrees is b by a, which is 1. Now to represent 60 degrees in a right triangle, consider this triangle that we had drawn with theta as 30 degrees here. Now if you look at this other angle, the other non-right angle opposite to theta, this one out here, it is 60 degrees, 90 minus 30. And therefore we can look at this triangle as a right triangle with one angle as 60 degrees, the base as b, the vertical side as a, and the hypotenuse as h. Therefore it is clear that sine of 60 degrees is a by h, which is root 3 by 2. Cos of 60 degrees is b by h, which is 1 by 2. And tan 60 degrees is sine theta by cos theta, which is root 3. And in a similar way, to represent 90 degrees, let us look at this triangle out here that we had drawn with theta as close to 0 degrees. And if we consider this other non-right angle here opposite to theta, as theta tends to 0 degrees, this other angle here tends to 90 degrees. And therefore we can look at this triangle where this angle is 90 degrees, the base is B, the vertical height is A, and the hypotenuse is H. And therefore sine theta is equal to A by H, which is equal to 1 because A is equal to H. And likewise cos of 90 degrees is equal to B by H, which is 0 because B tends to 0. And therefore tan 90 degrees is 1 by 0, which is a ratio that can't be defined. So we write it as not defined. Now that we have completed this table, it is good to also remember the values of these angles for which we have calculated sine, cos and tan in radians. So 0 degrees will be 0 radians, 30 degrees is pi by 6 radians, 45 is pi by 4 radians, 60 is pi by 3 radians, and 90 is pi by 2 radians. So far we have discussed the basic concepts of trigonometry, which will be useful to learn the trigonometry chapter of 11th standard of CBSE. And now I will see you in the next session.